Okay, and we're back. Okay, so we've got the mark where our combustion wheel will go. Right here, we've got the mark, which is just there, 0. That will be our key. First thing to go back is the can. Okay, so this has got to go in here. And this device, all the holes are specifically patterned to actually allow the burn of the A1 jet fuel, to make sure it's actually burning in the right place, to allow the air through and the mixture to create. It's quite specific. Okay, so all we need to do is make sure we orientate the spark plug here, or the ignition plug. Do that by just getting this in place, which is like that. This is the exhaust nozzle. When running, the fuel ignites and creates an expanding hot gas. This is forced through the nozzle vanes and into the turbine rotor, causing it to rotate. Okay, so before we can assemble the combustion can, we need to assemble the exhaust nozzle into the cover. So, combustion chamber. So I've got to quickly assemble this. Once these are in, it makes it really difficult to strip the engine down. So there's some sort of design reason for it, I don't know. Okay, so I've put the can in place, centered around the ignition spark plug, and I've put all these injectors in loosely just to locate everything, because I can't move it around. There's now one unit. Okay, so we're back to this one. What we're now got to do is put the sealer all the way around, and then we'll add the two halves together. That'll bring together the main engine components. I tend to use this for my high temperature gasket seals. It's a rubberized silicon mix. Quite high temperature, 315 degrees C, and the outside temperature of this is unlikely to go above about 250. It gets hot, but I'm not going to be running it for long periods of time, so this is the stuff I'm going to use. Okay, so I'm going to use some of this. I tend to put it on with a knife, only because it's easy to work with. There's no gasket on this. Just put this thin layer, otherwise it'll splurge out into the combustion area, just make more of a mess. And then we need to get all around the edges. If you put too much on, also it starts coming out around where all the nuts and bolts are. It just doesn't look very nice, and it's difficult to clean up. Just slow as you go. It's easy. If you've worked on cars before, you know exactly what I mean. You splurge it onto the gasket. Great stuff, got plenty on there. Tighten it up, all comes outside, trip it. If you end up getting any particles in it, then it's best to wipe that section off and redo it. Otherwise, you could end up holding the two halves apart, and then you end up with a gas leak. And considering what's happening inside here, you don't really want that. Right, we're ready to put the top on. One of the troubles I have with this is like a piston ring at the bottom that has to collapse as you push the top down. It's never an easy job, and it tends to actually bounce up and down, but you try and stop the two surfaces mating with each other. That's what you're actually trying to arrange the position. So let's give it a go. that's in. I normally do this, so I'll just move it backwards and forwards a little bit so that all the sealer grips. The final thing now is to get it lined up so that every single hole gives you easy access to put your bolts in. The bolts that came off the engine are Russian lock nuts, which are getting a bit tired, but these are the replacement ones. They're aero lock nuts. They're generally used on a lot of aviation engines. Because we're sealing this down, we've got to go around the outside, trying to tighten evenly, otherwise it will end up distorting the case. Right, that's good. So, what we're looking for is O. So that pin is going to line up with this one here. Notice the tabs are on the inside, not the outside, because the centrifugal force potentially could bend them back out, whereas if they're on the inside, if they do try and bend, they'll only make themselves tighter. I'll do that for now. Just leaves the lock tabs, which I'll come back and do later. Okay, back over to the compressor and take the cover off. This is a special coating that can be damaged quite easily, so we're going to put that to one side. Okay, so back to planning chamber. We're going to put some high temperature silicon sealer over the top, spread it around the outside and clamp the plate down. It's quite important to get this bolted down as you would a car cylinder head, alternating between each different side as you go around. I normally do it in a triangular fashion as we go around. It is difficult to get this casing off, so don't overdo it. Don't put too much on, you never know when you might be back here again. So we've got a nice thin coating all the way around, and I've made sure that most of the holes are clear of silicone. Otherwise, when we pad it on, it'll actually end up on all the threads. It's a pain in the backside to remove. Don't let it wobble around too much. Try and put it on as square as you can. Any excess silicone, now's the time to take it off, otherwise you get it all over the casings. All we're doing at this point is just bringing the case down onto its face. So we're about there. Now, if you've got this about right, you should be able to just turn the rotor slightly. There you go. That means the case is on square to the compressor chamber. Getting a little heavier now. Okay, so injectors and exhaust nozzle. So we're going to replace the injectors today. As I said earlier, we'd actually put all of these in loose. That's actually to hold the main can in place. Right, so it's a matter of just taking each one of these out, replacing the gaskets and putting new seals on. The actual seals inside in here, I normally put a bit of Vaseline on those, just a tiny dot, just to make sure they're all sealed up, because they are high temperature seals. On top of the actual valve itself, we actually use these copper washers to seal them down. These are just standard fuel injector seals. You can buy them from pretty much anywhere. If you're really stuck, you can heat them up and quench them, and that'll make the copper soft again, and you might be able to reuse them. Before you actually start assembling though, just make sure that they actually do cover and drop when they're down. What tends to happen is as you tighten them up, they'll actually squeeze and they'll actually push into the threads a little, and then they get really tight and they're difficult to take on and off, especially to take off when you disassemble. So I've either got new ones or replace the existing, whichever, it's up to you. Now I generally do this without gloves, that way I can see that if there's any muck and whatever you get in the way. The injectors point up in up position, ready for the high pressure fuel line to be added straight on afterwards. Now I've already put this on just to make sure we get a loose fit on it. It's always a good idea to get things just right for the injectors, because otherwise you'll end up actually tightening everything down and nothing fits. So what I'll be doing is putting all the injectors on with a little bit of give, drop this on, tighten up the injectors, and then put the caps on. Right, so I'll quickly whiz through and get those done. Remember, high temperature silicone, as little as you can get away with on gaskets. As I said just before we tighten up, I'm going to offer up my pressure fuel line. And this goes to the base at the bottom. And remember, this is just so I can locate it, it's not for tightening up just yet. The copper seals are going later. Got that on. So with that in place, I'm just going to nip up the injector bolts. We could actually buy standard copper washers from fuel injector specialists and what have you, but they generally tend to be a bit too thick. Here's one that's can you see out the distance, or the width of the actual washer is a bit too much. So what I've done, it's a pretty simple job. Just put a load on a bolt, put them in a lathe. You can then skim them off until you've got the right thickness. Getting the right thickness is quite important, especially where you've got recesses and what have you. If they're a bit tight and they sit just off, then you'll not get a good seal when you actually tighten up the fuel pressure. £15. What we're going to have to go pretty good tying back the nuts, stop them vibrating, so the anti-vibration. The wire you need is a stainless steel wire. It's relatively cheap, but you've got to get the annealed stuff. So in other words, it's a bit more pliable. The only thing with it is that it's, once you work, as in moved it around, it does get a lot harder, so it's more difficult to take off, and you just can't reuse the stuff because it makes a bit of a mess. Anyway, get the right size that you need. The nuts, these are pretty standard stuff for aviation machines, jet ends, etc. They've got holes that go all the way through, or they'll actually have to be on the corners depending on the type of nut. Generally they tend to be stainless steel, but traditionally with a lot of Russian stuff, especially of the era, it'll be of some sort of steel. You can tell that because there's a lot of rust and what have you that's happened over the years. I mean, we've cleaned these up as best we can. Generally what I do with the really good engines, if we're going to resell them or put them on display, we'll change them all for stainless steel nuts and bolts. Drilling stainless is possible, but if you see the size of the hole, we're talking about 1 millimeter there, it is really tricky to do and it takes quite a while, so it's better to buy them with holes in already. Okay, so I'm going to tie back the outer pair to start with. So put the wire in. It gets obscured. Don't want to worry too much about it. Don't start tying it the bolts up, because if you do, you could end up snapping the bolts or over torquing. All we need to do is just put it in at about a few millimeters and give it a bend up, so you end up with a slight curve on it. Push it in again, and this time when you wobble it through, it will actually make the bend. When you actually fold this over, you want both ends to roughly meet. In this case, I actually want it this way round. It takes a bit of practice to get these just as you want them. So we want both the ends to be about the same. Using the special tool. Grab the ends. So using the special tool, just get them so they're about level. Now we want to go around to this nut, so we only want to twist about halfway, because when I actually move it around, it's going to be about there. So that's sort of where I want to be. Push together and push the catch back. That would lock it into position, so it's ready. And all you need to do then, if I show the back, all we need to do then is pull the end and it will twist around. Just keep doing that. So we get just enough of what we want. A little bit more. Okay. Right. Just wobble it back as it falls like that. That actually pulls it tight up against the nut. A little bit more. Okay. Squeeze together. That releases the catch. Let's have a quick look close at what we're doing again. Okay, so now we want to go around to where this nut is. Wherever that bolt, the holes on that bolt line up, let's just find out where they are. There we go. This one's going to be quite easy. Nice. So now splay the two wires apart, pull it back, because I'm going to go in with this one. Right, push it all the way through. Use your pliers just to pull the cable through. Okay. Again. Clamp the cable, push the catch back. And just as it starts to get close, again, pull your cables together like that. Alright, they don't have to be perfect, that's good enough. Pull together, unlock the clamp. With the ends, because we don't want to get sharp edges, I'm just going to take that up a little bit more, take it right to the tip. Okay, that'll do. And cut it off. And then stop yourself getting caught on the edges. Just bend it over like that. There we go. And that way you won't catch your hands when you're working on the rest of the bolts. The nuts are secured now, so even with the vibration, it doesn't matter whether it's actually gripped it or whatever, because the actual twist in the wire stays put. So if the wire is through at whichever angle, not only has the bolt got to undo, it's got to move the cable from that as it moves it, and it's got to move everything else. So the wires, it's not necessarily pulling it tight, it's actually just holding it in place, that's all. So if any vibration of the nuts, it'll start to turn, then it'll press against the cable, it won't go any further. Good, that's the first one done, and we'll move on to the rest.